How much do you build yourself, your rover?
Like, of course, our team is comprised of students. So we also have to keep certain things in mind, like to how far we can go designing certain components with given our experience. We're also kind of lucky in the team to have a lot of professors and experts back us up with a lot of our decisions and how we go about stuff. There's a lot of parts that our students make. So, for example, the payload sensor is actually designed by a master student, and it's completely done by him. Again, our chassis is completely designed by our students again to house components in the most suitable way. Of course, like the chassis we don't manufacture ourselves because there's really small tolerances that we can't manufacture at the university. So we do outsource the manufacturing in that sense. Parts like our battery management system, again, we outsource this to different companies. So we're actually using a battery management system from an external company. And we try and, so given our experience, we can't really build this. So we're trying to use that from outside. Our legs are completely also designed by students. So we made those legs ourselves, and a lot of the optimization of the legs is also carried out by students. And in general, whatever we can do by ourselves to make the best part, we try and do. But again, there are certain like space grade elements of our rovers, such as the power system, and also some of the multi-layer insulation that we do outsource to other companies. Given their experience. Probably something very interesting as well is space soldering. So the electronics need to be soldered in a very specific way for space components. While we are trying to get our students to get certified with this and try and do the soldering themselves, at the moment we do rely on other people within the university with more experience to help us with this. So we're slowly trying to get there, slowly trying to make more of our rover design by students in new, innovative ways.
How did you design the Zebro?
The Zebro is very unique in the way it's designed. It does not really look like a conventional rover, given the ones we've seen on Mars, such as Curiosity. So the basis of the project actually came out of the RHEX project by the University of Pennsylvania. This project was the first one to utilize C-shaped legs. So they're really unique locomotive devices we have on the Lunar Zebro. However, that project was actually aimed on Earth terrain. So it did show the feasibility of these very unique C-shaped legs in crossing a variety of terrain through water, through high rocks and everything. So actually, the Lunar Zebro took a derivative of this design and tried to apply it in a moon setting. So that's where it began. And then on top of this, we added our science goals to show how we can get radiation readings of the surface of the moon. And on top of that, we also developed the cameras, SHRIMP, so that we can actually take pictures on here. So that's how Zebro was kind of put together from the initial concept of the C-shaped legs, now all the way down to our science goals. So that's a very rough timeline of how we designed it. And again, as we gain more experience through testing, things like that, this is how we get more details on how we can further optimize our design. So yeah, it's a very iterative process of us trying to converge to a really nice and optimal design.
Yeah, specifically, how did we design the Zebro? It's a lot of taking into account all the constraints you get when you launch something to space, to the moon, because you have a lot of on one side you have vacuum, which you have to take into account. You have radiation, which you have to take into account. So you have to make sure that your electronics are quite well shielded against those radiations, because that can cause big issues. What else do you have? You have all the dust on the moon. It's a bit of a layer of dust basically on the surface of the moon, which is quite annoying to design for, because it's electrostatically charged, which means that it's a bit like rubbing a balloon against your hair, for example. Then it starts to stick against your head. It's a bit the same thing, that these dust particles stick to our Zebro, and then you can imagine in every hinge, in everything, if the dust gets into there, it's annoying because it's also very abrasive. So it destroys your rover inside of it. So it's a lot of constraints that we have to look into when we go from the Zebro that went from the University of Pennsylvania and then to TU Delft, so the terrestrial Zebro. When we go from that to our moon Zebro, we had to rethink quite a bit on those practical sides.
A very good point Marnix brought up is the mass that we have. So just to put into perspective, a rough estimate of how much it would cost per gram. So we've seen that roughly every gram that we add adds up to like €1,000 to the cost of launch. So you can imagine every gram counts in to us for us to optimize the design. So two extra grams would cost us €2,000 more. So, and we really don't want to be spending that.
And that's why we're so proud about those shrimp cameras, for example, that we have, because they're so lightweight. We managed to save quite a bit of weight compared to different cameras. And we try to do that all over. Also, our C-shaped legs, if you want to know details, the fact that we use a C-shaped leg is, for one, because it can climb over obstacles so much easier than wheels. But secondly, it's much, much lighter than a wheel, because we basically have half a wheel or a third of a wheel, depending on how you look at it. Whereas a full wheel needs, spokes, and you need a circle thingy. We have something much simpler. Again, saving weight. That's what Jason said.
Do you use a modular design for the Lunar Zebro?
So we've designed the payload area, and our approach to payload on the rover, we've tried to make that modular in the sense that we can replace that space with another form of payload that we want. So that's one area that we've looked at to make it modular in that sense. However, it does become increasingly difficult with a space system to make it really modular. That at least in our experience, that's what we've seen, because making stuff modular means that there's not many solid connections in the sense that we can have. So we're still experimenting this. There have been proposals with our electronics team and some of structures to maybe go towards a modular design so that we can replace and do a lot more. But at the moment, it's not the center of our focus. As I said, we've made the payload area and the payload part of it as modular as we can, so that we can swap out stuff. But for the rest of the rover, for stuff such as the electronics and chassis, we're still experimenting in how we can kind of go towards some kind of modular design.
What material do you use to resist extreme temperature changes on the moon?
Yeah, that's a very interesting question, because as you can imagine, the moon really does not have an atmosphere. So the temperature fluctuations between day and night are like really extreme. So what material do we use? The main chassis of the Zebro is actually just aluminium. But to insulate the Zebro, we actually use MLI, so multi-layer insulation, as you see in other space missions and satellites. This really provides us with some thermal insulation to endure the large temperature changes we see. Apart from that, other interesting materials that we use are stuff such as CMC. So, and we use this on our solar panel. Sorry, I completely forgot the name of that. So we use that on our solar panel so that it can endure the extreme temperatures that the solar panel faces, because as you can imagine, the solar panel is directly in sunlight. So it was a ceramic matrix composite, to be exact, CMC. And this is what we use on the solar panel. And as I mentioned, MLI on this, basically the chassis of the rover, so that we maintain thermal insulation there.
Yeah.
And we also use a high performance material, a 3D printed material called Ultim. And this is also able to endure maximum temperature changes, such that the material does not fatigue expanding and contracting, causing more issues there. To answer your question of how long the rover will survive on the moon,